Hi everyone, welcome to another math session for AB Tutor, and where learning is as easy as A, B, T. Alright, welcome again. So today we'll be going through number theory, or part 1 video on number theory. Now at the end of this video, we should understand natural numbers, whole numbers, irrational numbers, rational numbers, integers, and finally real numbers. Alright, so starting off with natural numbers. What are natural numbers? Now, natural numbers are simply positive numbers starting from 1 upwards. Now, natural numbers are denoted, or the symbol for natural numbers is actually n. So therefore, n is equal to 1, 2, 3, and so on. And that is natural numbers. Now, what are whole numbers? Now, whole numbers are simply the set of natural numbers and 0. Now, the symbol for whole numbers is W. So whole numbers would be equal to, or the set of whole numbers would be equal to 0, 1, 2, 3, and so on. Now, we note right here that natural numbers are contained in whole numbers. Now, if we're not 100% sure what that means, check out our video on sets and it will be much clearer to you. Let's look at integers. Now, integers are positive and negative natural numbers, and they also include 0. Right? Now, integers, the symbol for integers is Z. Right? Now, integers, let's list some. It would be from negative infinity, obviously, to positive infinity, if we know what that is. And we will say, let's say, from that side to negative 3, negative 2, negative 1, 0, 1, 2, 3, and so forth. Now, we note that integers contain both natural numbers and whole numbers. Or said another way, natural numbers are contained in whole numbers and whole numbers are contained in integers, which means both are contained in integers. Now let's look at rational and irrational numbers. So far, we've looked at pretty much whole numbers and natural numbers. No fractions, right? No numbers that are fractions. Now, rational numbers include both integers and numbers that can be written as fractions. So both the negative and positive integers that can be written as fractions. They also include fractions and decimals, or decimals particularly, that have a terminating value, that means an ending value, for instance, 0.65, or a decimal that is reoccurring. For instance, 1 over 3 that goes 0.3333, reoccurring numbers. So that is what we would consider to be rational numbers. So those would be integers along with those fractions. Another example of a rational number is 1 over 2, or a half, or negative 1 over 4, or negative quarter. Now, let's ask ourselves, is 3 a rational number? Can 3 be written as a fraction? If we put 3 over 1, that's pretty much in a fraction form. So yes, 3 can be written as a fraction, and 3 would be considered a rational numbers. So all these integers are also considered rational numbers. So you know what I'm going to say now, right? That rational numbers contain integers. Did I get that right? Rational numbers contain integers. So all integers are contained in the set of rational numbers. We also know that rational numbers are symbolized, or the symbol for rational numbers is Q. Now let's move to irrational numbers. So irrational numbers, that's pretty much the opposite of rational numbers. But you could have told me that, right? So here's a better definition. An irrational number cannot be written as fractions with integers, right? Unlike, our rational numbers. And additionally, in decimal form, they do not terminate or have an ending, nor are they periodic. Now, what would be a good example of an irrational number? Think about the root of 2. Now, just punch that in your calculator and see, in decimal form what that looks like. Or the root of 3. So these would be considered irrational numbers. So rational numbers and irrational numbers are pretty much the opposite. Another way of looking at rational numbers and irrational numbers, we could say, and we learned this from our set theory video, check it out again, you could look at rational numbers are the complement of irrational numbers, or a rational number is a complement of a rational number, whichever way you want to look at it. So if we denote our rational numbers as Q, we can write our irrational number as Q complement. Now for our final one, real numbers. Now real numbers, this is the easiest and the hardest one at the same time, I guess. So real numbers would contain both rational and irrational numbers. So in set form, a real number or the set of real numbers is equal to the set of irrational numbers union the set of rational numbers. And that would be the universe of real numbers. Now, real numbers are denoted by the letter R. So R would be equal to Q union Q complement. And that's it for a part 1 video for number theory. I hope you enjoyed. As I always say, it was easy as A, B, T. Have a good one.